525 is titled Solving and Applying Quadratic Equations. So yesterday we learned the quadratic formula. Today we're going to look back at, well, we can always use the quadratic formula, but are there easier methods or in some cases faster methods to solve our quadratic? So question 106, it says, previously you learned the quadratic formula can solve any quadratic equation if it's in standard form, like ax squared plus bx plus x equals 0. But what if the equation is not in standard form? Or what if terms are missing? Is using the quadratic formula always the best method? Examine the quadratic equations below. Decide which strategy to try first. Solve each equation. If your first strategy doesn't work, use a different strategy. And then check your solutions. Okay, so the first one we're going to look at is the equation x squared plus 12x plus 27 equals 0, which is given to us in standard form. But before we use the quadratic formula on it, you want to check and see if it can be factored. Meaning, are there two numbers that multiply to get 27 and add or subtract to get 12? And in this case, there are, right? So it's going to be faster to factor this equation than it is to use the quadratic formula on it, okay? If we use the numbers 3 and 9, 3 times 9 is 27, 3 plus 9 is 12. So it's going to be easier to factor to x plus 3 times x plus 9, and then set each of those equal to 0, okay? That's called the zero product property, right? We learned zero product property last semester, and it basically says if you multiply by 0, you're going to get an answer of 0. So if either of these two factors is 0, then that'll make the equation true, okay? So either x plus 3 is going to be equal to 0, or x plus 9 is going to be equal to 0. And then we just do inverse operations to solve for our x. So we do the inverse of adding 3, which is subtracting 3, and we get x equals negative 3. We do the inverse of adding 9, which is subtracting 9, and we get negative 9. That was way faster than using the quadratic formula on this, okay? But could you use the quadratic formula? Sure. It's just going to take you longer. You would get the same answers, all right? Equation B, we have 4x squared minus 121 equals 0. Again, this is in standard form. And again, you could use the quadratic formula, but this one is going to be easier to factor. How do I know? Because the first term is a perfect square, and the second term is a perfect square. This one is actually a very special pattern called difference of squares, okay? Meaning a perfect square is being subtracted from a perfect square. So if we take the square root of 4x squared, we get 2x times 2x. And if we take the square root of 121, we get 11 and 11. And then you're going to notice that your signs are opposite. One of them's plus and one of them's minus. That creates opposites, which is why there's no middle term here, okay? Because they would cancel each other out. If you have, what would that be? 22x and negative 22x, they would combine and get 0, okay? Now we're going to use the zero product property by setting each of these equal to 0 separately and then solving. So the inverse operation of adding 11 is subtracting 11 from both sides. Then when you divide both sides by 2, you get negative 5.5. The other equation, we do the inverse of subtracting 11, which is adding 11. The inverse of multiplying by 2, which is dividing by 2. And we get positive 5.5. Most of the time, they don't end up opposites like this. This is kind of a very special case, okay? But it does happen sometimes. Part C is already factored for us. So us to even use the quadratic formula on this, we would have to FOIL it out. So that would take even longer that way. So definitely just go with the factored form, set each of them equal to 0, and then do your inverse operations until you solve for x. So the one on the left, we're going to subtract 4 from both sides. And then the inverse operation of multiplying by 3 is dividing by 3. And we get negative 4/3. For the one on the right, the inverse operation of subtracting 1 is adding 1. And then the inverse operation of multiplying by 2 is dividing by 2. And you can write those answers as fractions or decimals, right? Notice in D, I left it as decimals. In C, I left it as fractions. You can go either way, whichever it's kind of a preference, okay? Any questions on A, B, or C? All right, let's check out D, E, and F. There we go. Okay. All right, for D, we have the equation x squared plus 12x equals 8x minus 4. Not quite in standard form, but actually really close to standard form, okay? So all I did is move the two terms on the right side of the equal sign over to the left side of the equal sign in order to set it equal to 0, okay? So the inverse operation of adding 8x is to subtract 8x, okay? And the inverse operation of subtracting 4 is to add 4. So you're going to add a 4 to that 12, which gets you 16, okay? Once it's in standard form, you could use the quadratic formula on this one, except it's easily factorable, okay? The square root of x squared is x times x. Square root of 16 is 4 times 4, but because this term is negative, they both need to be negative. So we're going to take one of these factors, since they're both the same, and set it equal to 0. The inverse operation of subtracting 4 is adding 4. We would get the same answer twice. If you want to show the work for that one, again, you can, but you don't need to because you're going to get the same answer. Okay? Part E is 36x squared minus 60x plus 25 equals 0. This one looks super complicated, like, oh man, I should probably use the quadratic formula on this one. But it just so happens that we have a bunch of perfect squares again, okay? I move this 60x over to the other side by subtracting it. And I can easily see that the 36x squared is a perfect square. It's 6x. And the 25 is a perfect square. The square root of 25 is 5, right? Because this is negative, I need a negative sign there. And it appears twice, just like the x minus 4 did over here. Here I wrote them out separate. Here I wrote it as the factor squared. You can write it either way. It's kind of like, do you prefer this or do you prefer this? It's just a preference thing. Or you can switch. I did one of each, all right? So I'm going to take that factor of 6x minus 5 and solve. The inverse operation of subtracting 5 is to add 5 to both sides. And then the inverse operation of multiplying by 6 is dividing by 6. That would give me a weird decimal, so I just left it as a fraction. But we would get that same answer again if we did it with the other factor, okay? The last one, letter F, is 20x squared minus 30x equals 2x plus 45. First thing I need to do is set it equal to 0. So I'm going to subtract this 2x, and if I have negative 30x already, that gets me negative 32x. And I need to subtract that 45, so that gets me negative 45, and that sets my equation equal to 0. This one is, excuse me, this one is not easily factorable. And so I chose to use the quadratic formula on this one, okay? Quadratic formula we learned yesterday. You're going to take the coefficient of the x squared, that becomes your a. The coefficient of the x, that becomes your b. And the constant term, which is negative 45, becomes your c. You're going to take those three numbers and you're going to plug them into the square root, which is x equals negative b. b is negative 32, gets plugged in there. Plus or minus the square root of b squared, which is negative 32, minus 4 times a, which is 20, times c, which is negative 45, all over 2a, which is 20. So the first step, you just want to plug everything in. Don't try and simplify quite yet. Wait till this next step to simplify. Okay? So you're going to take the opposite of negative 32, which is positive 32. Rewrite your plus minus, and then use your calculator, right? Unless you can multiply 32 times 32 in your head. I don't know. Maybe you have some super multiplying trick, okay? So negative 32 squared is 1,024. And then negative 4 times 20 times negative 45 is plus 3,600. Under that radical, we're going to add the 1,024 and the 3,600 to get 4,624. Woo! Then we're going to do two problems here, one with addition and one with subtraction. So let me show you how to type it in the calculator, just like I did yesterday. So let's do the plus first. So 32 plus the square root of 4,624. Hit the equal sign. Then we're going to divide it by the denominator of 40. That one turns out to be exactly 2.5. So that's my first answer. Now let's do it with subtraction. So we're going to do 32 minus the square root of 4,624. Hit the equal sign. And then we're going to divide by the denominator of 40. And we get negative 0.9. And that's our two answers. All right. We are going to skip question 108. You can just write skip and draw a line. And that's it for today.